Welcome back to another explainer. Today we're tackling something absolutely massive. It's essential to global trade, yet it's completely misunderstood by most of us. We're talking about the high-stakes logistics of global vehicle transport. Seriously, if you've ever seen a brand new imported car driving down the highway, you are actually looking at a survivor of some of the most extreme engineering challenges on the planet. Okay, let's dive into this because this question right here, it is the ultimate engineering paradox. How in the world do you safely sail a hollow 12-story metal box, literally packed with 8,000 fuel-loaded cars, across a violent, unpredictable ocean? It sounds like a total recipe for disaster, right? But believe it or not, this happens seamlessly around the world every single day. Just look at the sheer scale of what we call a ro-ro vessel. That stands for roll-on/roll-off. Unlike a traditional cargo ship where giant cranes are lifting boxes over the side, a ro-ro is basically a floating parking garage. The size of these things is just staggering, and they are designed for one main objective: very fast turnaround times. You have this endless stream of road haulage vehicles, cars, and goods just being wheeled directly in and out of a massive internal cargo compartment. Section 1, the floating parking garage. Let's take a look at the anatomy of a pure car and truck carrier, or a PCTC. Check out this cross-section. It shows exactly how these ships handle that massive volume. You're usually looking at about 12 distinct decks in there. Now, the absolutely crucial thing here is how they deal with gravity. To keep this giant hollow structure from just tipping right over, they put the heavy stuff, the fuel oil tanks and the water ballast, way down at the very bottom. A couple of those lower decks are fixed in place to handle incredibly heavy cargo. But the heights of the other car decks above them, those are actually adjusted hydraulically. This movable decking gives them the flexibility to load anything from a standard little sedan to massive construction machinery. And when they optimize all that space, the capacity is just mind-blowing. The largest of these car carriers can hold upwards of 8,000 vehicles at a single time. I mean, just picture a parking lot with 8,000 cars, stacked 12 stories high, floating out on the open sea. Of course, out on the open ocean, packing a giant hollow box with 8,000 cars means you are constantly fighting physics. Section 2, the engineering dilemmas. Fighting physics on the open ocean. This perfectly captures one of their biggest inherent dangers. Notice how insanely tall the sides of the ship are? This high wall-sided design completely encloses and protects the cargo, sure, but it creates what marine engineers call a massive windage area. Basically, the entire ship acts like a giant sail. When they're at slow speeds or just sitting at anchor, strong winds can catch the vessel broadside, causing massive yaw that essentially twists the ship right off its course. It can even cause them to drag their anchor or snap those thick mooring ropes right at the berth. Maneuvering a beast like this in high winds is incredibly difficult. But, wind isn't the only threat out there. Let's talk about water actually getting inside the ship. Slack water is a terrifying term in ro-ro operations. Because these ships need massive, wide-open decks to move cars around quickly, they have very few internal walls or bulkheads. That introduces a massive hazard known as the free surface effect. If the ship's fire prevention sprinklers go off, or if there's a leak, water can rapidly accumulate and just slosh back and forth across these huge, wide-open decks. All that shifting weight can cause a rapid and fatal loss of stability. So to fight the constant roll of the ocean and keep the ship from tipping, engineers use some pretty brilliant stabilization systems. They basically fall into two camps, passive and active. Passive systems use these big U-shaped tanks filled with water and internal baffles. As the ship rolls to one side, the baffles slow the water from sloshing back to the other side. This effectively traps weight on the higher side to push the ship back down. Now, active systems require power. They use gyroscopes to detect the ship's rolling motion and instantly deploy these underwater fins that push against the water to counteract the roll. It's just this constant mechanical battle to keep the deck flat. Section 3, securing the massive cargo. The meticulous geometry of lashing. Now, all those fancy hull stabilizers aren't going to help much if 8,000 cars suddenly slide across a steel deck. The geometry they use to prevent this is fascinating. Look at these insanely strict parking parameters. The vehicles are packed incredibly tight. Specifically, they are allowed a maximum of 30 centimeters between bumpers and just 10 centimeters between doors. Why pack them so close together? Because if the securing lashings were to somehow fail, this dense packing physically restricts the cars from gaining any momentum. They literally can't move transversely across the ship. But getting this right requires intense microscopic supervision from the ship's officers. Locking these cars down is an absolute science. Dock workers, known as stevedores, have to follow a really strict protocol before the ship even thinks about leaving the dock. Step 1. Switch the engine off and leave it in gear. Step 2. Firmly apply that parking brake. Step 3. Chock the wheels to prevent rolling. And Step 4. Apply the tension lashings. And notice the angle on those lashings. They are considered most effective specifically when placed between 30 and 60 degrees relative to the deck line. Now, what's really interesting about this setup is how those lashings actually grip the ship. On one side, you've got the chain load binder mechanism, and on the other is what deck crews call a star point, or an elephant's foot. These anchor points are literally welded directly into the steel deck. The lower hook of the chain fits perfectly right into that star point. This allows a load binder to tension the chain so tightly that even if it slackens a bit from the constant vibration of the voyage, it simply won't detach. And hey, it's not just cars making the trip. When they ship massive uncoupled semi-trailers, the rules get even stricter. You absolutely cannot just drop a trailer on its own landing legs. That focused weight would severely damage the deck, or the legs could just straight up collapse under the rolling motion of the sea. Instead, they require specially designed weight-bearing trestles to support the front end. And that's backed up by really robust 6-point chain lashings to hold the whole rig completely stationary. Section 4. Surviving invisible threats. Managing the atmosphere inside the belly. Right, so physical movement isn't the only thing the crew has to sweat over. Think about it. You've got thousands of internal combustion engines driving around inside a closed-off metal box. The atmosphere in there can turn deadly in a matter of minutes. The crew has to constantly monitor for a terrifying checklist of invisible threats. Carbon monoxide from exhaust can cause rapid poisoning. Flammable hydrocarbons from fuel vapors can create a literal explosive mixture. Hydrogen sulfide can build up, and simply running all those engines in a confined space can deplete the oxygen, creating a hypoxic environment. This is exactly why strict no-smoking rules and continuous fixed atmospheric monitoring are absolute life-or-death requirements. To combat all this, they need a massive mechanical ventilation effort. I mean, massive. Whenever vehicles are operating during loading or unloading, these heavy-duty continuous ventilation fans absolutely must be running. The system has to work incredibly hard to guarantee the atmosphere stays above 20% oxygen, and it has to keep that highly toxic carbon monoxide content well below 30 parts per million. Section 5. Sealing the hull. Defending the ship's most vulnerable points. Okay, we've reached the most critical vulnerability of any ro-ro ship, and that's the massive, totally necessary holes cut into the hull right near the waterline. To drive cars on and off, the ship literally has to open itself up to the ocean. Just look at the mechanics of this massive watertight bow door. The front visor actually lifts up using these heavy hydraulic operating cylinders. But right behind that, you have a top-hinged watertight door. This isn't just a door to keep the breeze out, it serves as the ultimate collision bulkhead. It has to perfectly maintain the watertight integrity of the ship against the relentless pounding of the ocean waves. And this brilliantly illustrates the setup at the back of the ship. Moving to the rear, the stern door actually doubles as the loading ramp itself. Once all the cargo is on board, heavy winches and hydraulic cylinders pull this massive steel ramp up, locking it into the casing with hydraulically operated bolts. It literally folds up to become an impenetrable, watertight seal against the ocean. But opening these massive steel doors isn't as simple as just pushing a button. It's a meticulous, highly supervised procedure, and it requires the explicit permission of the ship's master. First, they disengage the manual securing cleats. Then, the door opens up. The ramp is lowered incredibly carefully to the shore linkspan. That's the connecting bridge to the dock. But here is just an amazing engineering detail. Step 4. Once lowered, the hydraulics must engage a free float position. This lets the heavy steel ramp freely move up and down with the ocean tides. If they didn't do this, the shifting tide could easily snap the ship's massive hydraulic rams right in half. Because these doors are literally life and death, the fail-safes are extensive. Up on the navigation bridge, the officers have indicator panels giving them constant visual and audible alarms, just verifying those doors are shut tight and locked. They also have a dedicated water leakage detection system and live television surveillance. If even a single drop of the ocean breaches those vital doors, the bridge knows immediately and the alarms will sound. So, what does this all mean for us? Well, the next time you see a brand new imported car cruising down the highway, I want you to ask yourself, what invisible engineering marvels brought it safely across the violent sea? From 12-story floating parking garages to gyroscopic stabilizers, extreme atmospheric monitoring, and massive watertight hydraulic seals, the sheer human effort and intense logistics behind global trade are truly breathtaking. Thanks for joining me on this explainer, and keep your curiosity rolling.